makes 150 rpm. The crank OA rotates with a speed of 150 rpm in anti-clockwise direction shown in figure. Now find for the given configuration the velocity of point P by using a relative velocity method. The dimensions of all the links are given here. As per the dimensions, you have to draw the configuration diagram. Okay. Then you have to find out the omega OA, because the speed of OA is given here. I have to find out the omega OA is equal to 2 pi n. N means speed of the input link OA divided by 6. So once you will get the omega OA, you can easily find out the velocity of A or velocity of A with respect to O. We know the formula: velocity A is equal to R means length of the link OA in meter into omega OA. Hey, anyone tell me what is the magnitude of omega OA? What is the magnitude of omega OA?
150.
1. How much? Hello? What is the magnitude of omega OA? Already we have done it. कितना है velocity omega OA? Okay, omega OA is 15.7 and velocity A is 2.35. How much? 15 point? 15.7 radian per second.
15.70.
15.70 radian per second, and velocity is
2.35.
2.05 meter per second. Okay, once you know the velocity of input link, you have to take down the scale here to draw a vector diagram. I'll take a scale. I'll take a scale here 1 centimeter, or you can take down randomly the scale. Directly I will take here 4 centimeter is equal. 4 centimeter is equal to 2.05 meter per second. Okay, means you have to draw a first vector OA. You have to draw a first vector OA whose magnitude is 2.05 meter per second, is nothing but your 4 centimeter. Is it right? Yes or no? भाई समझ में आ रहा है कि नहीं सबके? Julie, Lohit?
Yes, sir.
Yes, sir.
Correct. And give me the response then. Now, sir, you have to draw the first vector OA of 4 centimeter. Okay, before that you have to look at the O. O is a fixed point. Now, in the given mechanism, how many fixed points? In given mechanism, how many fixed points? Anyone? 2, na?
2.
This one and this one means O and Q. You have to take down the O and Q are the fixed points at the same location. I will choose this location. Okay. Now draw the first vector OA, which is 4 centimeter, and it is perpendicular to OA in the direction of rotation. It goes the 4 direction. This is the first vector. Our first vector OA perpendicular to link OA in upward direction, and it is of 4 centimeter. Now this is nothing but your velocity of A. This is nothing but your velocity of A, and it is known. Okay. Now next, you have to look at the next point. Which point you have to look at here? When you draw the configuration diagram, you have to look at the first V point. Okay, means you have to take down the A as the center and distance AB, draw R. Take down Q as the center and distance QB, draw R. You will get the intersection point B. Similar way, you will get the intersection point of vector AB and QB is your B. Okay. Now through this A, you have to draw the next line perpendicular to this AB. This is nothing but your vector AB. Then you have to take down the Q as a center, Q as a point, and through this Q you have to draw the next vector QB, which is perpendicular to the link QB. Intersection point is nothing but your B. Okay, means I will draw first vector from this A is your AB. You have to extend on both sides and draw this vector, and it is perpendicular to AB. Next, I will draw through this Q. Now this is the Q. So this Q, I will draw the next vector QB perpendicular to QB on both sides. Now intersection point is nothing but your B.
Sir, velocity 2.3 आ रहा है.
Okay, you have to take down whichever is the answer. Okay. Now you will get the intersection point B. You have to look at the arrow here towards the B. Is nothing but your velocity of B with respect to A. Now towards B is nothing but the velocity of B with respect to fixed point Q. You will get this B point. After that, you have to look at the C point. Again, when you draw the configuration diagram, you have to look at the C point by taking the Q, A as a center, distance AC, draw arc. Then you have to take down B as the center and distance BC and draw arc. You will get the intersection point C. Similar way, you have to draw the vector AC and draw vector BC. The intersection point is nothing but your C. I will take here A as a center. Through this A, I will draw a next perpendicular line is your AC. A. Through this A, I will draw a perpendicular to this AC. Through this A, I will draw a line AC which is perpendicular to the link AC. Extend it. Now through this B, I will draw the next line which is perpendicular to BC. The intersection of point of vector AC and BC is your C. Through this B, I will draw the next vector which is perpendicular to BC. Suppose like this. Okay, where these two vectors intersect, you will get the C point. This is nothing but C point. Okay, you will get the C point. Now you have to show the hatching portion. Now A, B, C is nothing but your ternary link. You will get here the ternary link. Now first vector is your AOA, then AAB, then QB, then AC, and B. Okay, in this way you have to locate the C point. Then you have to locate the next one is your piston P. You have to locate the point P, piston. For that you have to draw the next vector through this C is nothing but your CP. And next one is the motion of the piston from fixed point Q. You will get the intersection point is your P. And through this C, I will draw a next vector which is perpendicular to this PC. Okay, and I will draw the motion of the slider P from the Q point, and it is a horizontal line. Where these two intersect, you will get the Q point. Or understand all of you? Nothing but Q. Okay.
Yes, sir.
Okay, now I have to show the arrows away from the previous point, and you name the name of this velocity. For example, away from this C point towards the Q is your nothing but velocity of Q with respect to C. Away from Q, sorry, this is your P pointer, not P. This is P. P with respect to C. Away from Q towards the P is your velocity of P. Like this, you have to give the name. Okay, now you have to find out here the velocity of which one? Piston. Now velocity of piston you will get here. Velocity of piston means the velocity of P with respect to fixed point, means you have to measure here the QP distance or the vector QP into scale is given here 2.03 or 0.5 meter per second divided by 4. Now this is nothing but your velocity of piston. Got it? All of you understand? Hello? Okay, are you understand all of you?
Yes, sir.
सर याची स्टार्टिंग ओ ए पासून स्टार्ट करायची ना
Now first vector you have to draw whose velocity is known. Now velocity of O is known, means you have to draw the first vector OA. Okay. Are you understand all of you? Or not? If you have any doubt, ask me.